Hey everyone, so today we're gonna talk about special right triangles and its relationship to the unit circle. Now, what do we mean by special is that we come across some common angles when we deal with right triangles in trigonometry, and they're the following. So we have what we call our 30, 60, 90 right triangle, 30, 60, 90, and that means 30 degrees is here or here, 60 is on the other acute angle or here. And what we have are special relationships between the sides and the angles. Normally we frequently see these numbers or angle measures. And then we also have the 45-45 special right triangle, 45 degrees here, 45 degrees here. Now for the 30, 60, 90, obviously the two sides, all three sides are different, but for the 45-45, since it's an isosceles triangle, two of the sides are going to be the same here, so that's pretty nice. Since we're still working with the unit circle, our hypotenuse, or the radius of that unit circle, is still going to be 1, and we just need to figure out what these other two sides are. So what I'm going to do, I'm going to draw the 30-degree angle here, and I'm actually going to draw it straight across, because we're going to continue to fill out the rest of the unit circle as we progress through the video. So here we have our 30-degree angle, and I'm going to just drop this down to create the right triangle. I know this is 1, and I'm trying to figure out this side, this bottom side, and this height side. So since there are two unknown sides, we can't use the Pythagorean theorem. We're going to have to use the trig functions. So let's start off by redrawing. I'm actually going to complete this first. So 30, 60 here, 60 there, and then I'm going to redraw this version like somewhere down here. So again, we have a 30, 60 triangle scenario. We know this is 1, this is our x, this is our y. Okay, so we know that sine, we use cosine, but let's start with sine. We know that sine is opposite over hypotenuse, so sine of 30 is y over 1. Since it's just over 1, it's just sine of 30 equals y, and the question is, what is sine of 30? So what you're going to do, you're going to make sure that your graphing calculator is in degrees. You're going to type in sine of 30, and you're going to get 0.5. Now, you want to keep most of your answers, you want to keep all of your answers actually in some type of fraction form or a whole number, since it's commonly seen that way in textbooks or some type of assessment. So since sine of 30 is 0.5, we're going to just rewrite that as a half. Okay, so we have 1/2 equals here, and I'm just going to write it up here as well. So 1/2 is here. Alright, now that we actually have two sides, we can use the Pythagorean theorem. So we know the Pythagorean theorem is a squared plus b squared equals c squared. So we have our a, our b, and our c. So x squared plus 1/2 squared equals 1 squared. X squared plus 1/4 equals 1. Subtract 1/4 from both sides. We get x squared equals 3 over 4. Since we're going to take the square root, there's going to be a plus or minus. And we want to apply the square root to both the numerator and denominator. Now, the square root of 3 doesn't give us a whole number, so we just leave it as square root of 3. And the square root of 4 is 2. So we see that we have two answers, a plus version and a minus version. Since we're in the first quadrant, we're only going to take the plus version, but we'll definitely see the minus version later on. So this is definitely in the first quadrant. Now I can fill out the rest, so I'm going to rewrite here as square root of 3 over 2. And I'm going to write over here square root of 3 over 2. Oops. Okay, now recall from a previous video that when you have an xy coordinate, it's the same as having a cosine theta, sine theta coordinate. So, since the value of cosine theta at 30 degrees is square root of 3 over 2, our coordinate is going to be square root of 3 over 2 first. And then our sine theta is going to be 1/2. And then we'll just fill out the rest based off of this and the 45-45. So let's actually look at the 45-45 triangle. So I'm going to draw that. in the best position possible. So 45 degrees here. I'm going to just dash that here. I'm gonna finish that off here. Okay, so then we kind of have the same setup. We have a right triangle, and we're trying to figure out the rest of the sides. So because this triangle is an isosceles triangle, we know that two of the sides are going to be the same. If this is x, then this has to be x. And we have our 1 here. So because there's two sides that are the same, that means we can just go straight to the Pythagorean theorem. So we have x squared plus x squared equals 1, 2x squared equals 1, x squared equals 1/2. Now, when we end up taking the square root, we have x equals plus or minus 1 over the square root of 2. Now, we normally don't leave our answers with radicals on the bottom. We have to do something called rationalizing it. So that means we just need to get rid of the radical. In order to get rid of a radical, you multiply it with itself. So multiply the bottom and top by square root of 2, because you're technically multiplying it by 1. Then you end up getting x equals plus or minus square root 2 over 2. Now, because we have a positive and a negative version of that answer, we're going to take the positive version because we're in the first quadrant. Alright then, so we have root 2 over 2 here, root 2 over 2 here. For our coordinate, it's going to be root 2 over 2, root 2 over 2. We're pretty much good to go. Alright, then let's start filling out the last part of the first quadrant, which is the 60-30 version, or the flip version of the 30-60. Okay, so I'm going to draw that. Okay, just going to continue filling these out. So this is our 60-degree, 30-degree version of the problem. Now, what we can notice is that the angles are just switching from 30-60 and 60-30. So if the angles are just switching, well, that means the coordinates are just switching. So we actually have 1/2 root 3 over 2 up here as well. Okay, we have the first quadrant filled out. We can easily fill out the second, third, and fourth quadrant by using our understanding of reflections from geometry. So let me just label these, and let's start filling them out. Okay, so let's see. To get from 30 to 45, that was plus 15. So again, we have 0 degrees here, 90 degrees here, 180 degrees here, 270 down here, and back at 360. Alright, so if we take 90 and add 30, we're going to get 120 degrees. If we add 15, we're going to get 135 degrees. Let me actually not put it up here. 120 degrees. If we add another 15, we should be getting 150 degrees. Okay, and these are all pretty much symmetric. So this 60 reflects over the y-axis to get to the 120, this 45 to get to the 135, and this 30 to get to the 150. Okay, so if they're just reflections, that means signs are changing. So if we reflect this point over here, over the y-axis, the x-coordinate sign is going to change, and the y-coordinate is going to stay the same. So instead of positive 1/2 and positive root 3 over 2, it's just going to be negative 1/2, remaining positive root 3 over 2. Okay, next one. So radical 2 over 2, radical 2 over 2, that's just negative radical 2 over 2 and positive radical 2 over 2. We end up with negative radical 3 over 2, negative, and 1/2. So we're done with quadrant 1 and 2. Okay, so let's fill out the rest. So we have 180 here. Okay, we can just fill out the rest by adding 30 or adding 15. So adding 30 we'll get 210. Adding 15 we'll get 225. And then we'll get 240 here. And then to 270. And then I can just fill out the rest, actually. We have that. We have that. And then we have that. Okay. So we have 270 here. We have 300, 315, and that's 330. Yeah, that's 330. Okay, so see, 30 and 210, they're opposites of each other. Since we're in the third quadrant, you know, we're going to have both of these to be negative. So negative root 3 over 2, negative 1/2. For here, we end up having negative negatives for both. So negative root 2 over 2, negative root 2 over 2. This is just negative 1/2, negative root 3 over 2. Sorry if it's getting a bit messy, but you're getting the idea. You can also just reflect over here. It doesn't have to be over here. Since we're reflecting over here, this is going to be positive x negative y. So positive 1/2, negative root 3 over 2. This is just positive 1/2, so root 2 over 2, negative root 2 over 2. And then last but not least, we have positive root 3 over 2, but negative 1/2. And we're finally done. So what I would emphasize is that you definitely remember what's going on in the first quadrant, and then you use your reflection properties to figure out the rest in the second, third, and fourth quadrant. And that's pretty much it. If you have any questions, leave them in the comment section, like and subscribe, and I'll make another video later. Bye!